separate the ions from one another. So they will start to form a sphere of water molecules around each of the ion. So this sphere of water molecules, we call them as hydration shell. Okay, so if a question asks you, briefly explain about hydration shell. So hydration shell is a sphere of water molecules when an ionic compound is dissolved in water. Okay, so remember that. Okay, so when these charged ions or polar molecules are dissolved in water, they will be separate or they will be surrounded by water molecules. Okay, because of their charge or partial charge. Now, that is the universal solvent. Next one is another important properties of water. Okay, so as you know, water can travel from the root to upper part of the tree. Okay, through xylem lah. After the root, then they enter xylem, and then they can reach upper part of the tree. So this is transporting water against gravity. So how is this possible for the tree to transport water, okay, from top to upper? So here, okay, the secret lies in which water have cohesion. Okay, cohesion, and this cohesion and adhesion lah. So cohesion, what it means is that where the hydrogen bonds hold water molecules together. So that is cohesion. Okay, when one water molecules hold another water molecules. And also adhesion is the attraction of water molecules with different substance. For example, here inside the root, okay, so the water will enter from the soil to the root, and then it will go through the cortex, and then until it reach the xylem. So the attraction or interaction of water molecules with the cortex cells and also with the xylem, okay, so we call that as adhesion. Okay, attraction of water molecules with different substance, with other substance. Okay, so remember, water has cohesion and adhesion, which helps to transport water against gravity in plants. Okay. Adhesion and cohesion. Next is water also has high surface tension, and also this is being helped by cohesion. Okay, so in this part, okay, cohesion is still talking about how the water molecules hold each other together. So how the water can have or exhibit high surface tension? Okay, so remember the water will always want to attract one another, whether the water molecules is next to them or above them or from underneath them. Okay, they will always try to pull one another together, like this one. But in the case of water molecules on the surface, okay, like this one, for these water molecules, since there are no other water molecules above them, okay, there are only water molecules beside them, next to them, okay, left or right, or underneath them. So their attraction or their pull is more towards one another and also inward, ke dalam. Okay, but there are no water molecules above. So when they start to pull one another side by side or inward, so this pull will start to create a surface tension, and this pull will give them like on the surface they will start to have like a membrane, okay, like a film that act like a membrane. So we call that as surface tension. Okay, a measure of how hard it is to break the surface of a liquid. Okay, that is why when we saw a drop of water, you normally can see them like this lah, like a sphere. Okay, so this is all because of the surface tension of water. Okay, next, water has a high specific heat capacity. Okay, here what it means is that for the water when the water receives heat, okay, the water normally will start to vibrate. But in order to do so, for the water to start to vibrate, it actually need a certain amount of heat. Okay, so here, to raise the temperature of 1 kilogram of water by 1 Kelvin, it actually requires 4.2 kilojoule of heat. Okay, so meaning here is that it is not easy to raise the temperature of water. So, when you raise the temperature of water, you actually need a large amount of heat because you are actually trying to break the hydrogen bond. So this makes the water as a good temperature buffer. Okay, so it allows the water content inside our body allows us to maintain our temperature. Imagine, especially for habitat aquatic organism. Okay, imagine if it is too easy for you to raise the temperature of water. Let's say on a very hot summer day. Okay, so meaning here is that if it is on a hot summer day, the temperature of the water, either it is inside the lake, it is easy for you to increase the temperature. If they have a lower heat capacity, it is easy for the temperature of the water to, in body water, to rise. So if this happen, what happened to all the fish inside the sea or inside the lake? Okay, they will suffer from the increasing temperature. So thankfully, water has high specific heat capacity. So they are very good temperature buffer. Okay. Next is water has a high latent heat of vaporization. So the same concept here. Okay, you need a very large amount of heat, a certain amount of heat, then only you can break the hydrogen bond of the water molecules. So here you need to break the hydrogen bonds to change the water liquid into gas. Okay, so in order to do so, heat of vaporization, the liquid must absorb 1 gram of, okay, to be converted to gas. Okay. So heat of vaporization, is the heat of a liquid must absorb for 1 gram of 1 gram to be converted to gas. So it means here is that the same like heat capacity just now, they need a larger amount of heat just to break the hydrogen bonds. Okay, for the liquid to be able to break the hydrogen bond and then for them to move quickly until they can be converted to gas. Okay, so if vaporization happen, okay, if a liquid evaporates, their remaining surface will become cool. Okay, so we call this as evaporative cooling. So this evaporative cooling also help to stabilize temperature in organism and bodies of water. Okay, so that is heat of vaporization. And next is the lower density of ice. Okay, here if we can see that the ice is lower density than water. So that is the reason why the ice can float on top of water. So the reason here is still the same. It is all because of the hydrogen bonds of the water. Okay, similar like the heat capacity, heat vaporization just now. All of that is because of the hydrogen bonds. Okay, so here the hydrogen bonding of the water makes the ice become more ordered. Okay, when you lower the temperature like any other normal other substance, okay, when you lower the temperature they will start to have restrict movement, less movement. So normally the molecules will start to closely pack with one another, so they will form solid. If they form solid, they will have higher density than water. But it is in contrast to ice. So ice, because they have hydrogen bonding, instead of they becoming closely packed with one another, okay, they will be like this. If you can see the animation here, okay, they have an orderly form. Okay, they are not closely packed with one another. So this structure makes the ice has lower density. Okay, so below 4 degrees Celsius, normally the water will become ice and they will have lower density. Okay, so like this one. So in liquid water, the molecules are actually, the water molecules actually can still move. Okay, they can vibrate, they will form bonds, hydrogen bond with another water molecule. They can break the bond and form another bond with another water molecules. Okay, that is for liquid. Okay, constantly break and reform bonds. But in ice, okay, when the temperature is lower, they have restrict movement. Okay, they have less movement. But instead of becoming more closely packed, they will form this orderly arrangement. Okay, this is all because of the hydrogen bonding. Okay, so these are the one that makes ice less dense than water. Imagine if it is the opposite. Okay, if they behave like any other normal solid, they will imagine if the water temperature lower, okay, they start to form ice. But in this case, if the ice is not like this structure, they become close with one another, they will have higher density. If that happen, okay, ice will sink, all ponds, lakes, and even ocean will froze solid, making life impossible. Okay, so that will harm the aquatic organism. So of course, thankfully, because of the properties of water, it is the opposite. Okay, so when the water reaches below 4 degrees Celsius, the ice will have lower density than water. Okay, so once again, there are 4 properties of water. Okay, that helps in environment. Okay, that helps in the life of living organism. First is the cohesive behavior, the transport of water inside the tree just now. Okay, and then ability to moderate temperature, the evaporative cooling, and the water can be a buffer just now because they have high specific heat capacity. Okay, they can help to maintain the temperature in organism and bodies of water. Okay, because it is not easy to raise the temperature of water. And then expansion upon freezing. Okay, that is the reason why ice has lower density than water. And then versatility as solvent. So this is because of the density. Okay, so next we will move to carbohydrate. But before we move to carbohydrate, I will give you all a break, 5-minute break. Maybe you need to refresh yourself or take a toilet break or something. Okay, so I see you after 5 minutes, which is 9:30. Okay, boleh? Okay, so those who stay online while waiting for the 5 minutes, you may watch this video lah. Okay, I hope you can hear. So I see you after 5 minutes.